Imagine pushing against a wall. Your hands press forward, but instantly you feel the wall pushing back with the exact same force. This simple moment is the heart of Newton's third law of motion. For every action force, there is an equal and opposite reaction force. In this chapter, we shift from looking at forces on a single object to understanding how forces always appear in pairs between two objects. And once you see it, you notice it everywhere. Let's start with a simple idea. Whenever one object exerts a force on another, the second object simultaneously exerts an equal force back. These forces are always equal in magnitude, always opposite in direction, and always acting on different objects. Picture a spring-loaded toy cart shooting a ball forward. When the spring releases, it pushes the ball forward. That's the action force. At the same moment, the ball pushes back on the spring and the cart with an equal force. That's the reaction. The ball moves forward, the cart moves slightly backward. Two forces, same size, opposite directions, acting on different objects. This also means action-reaction forces never cancel each other out because they don't act on the same object. If they did, nothing would ever move. So when you see forces on a free body diagram balancing each other, like gravity and the normal force on a book, those are not action-reaction pairs. They're just forces acting on one object that happen to cancel out. The third law is different. It's about forces between objects. Now think about an apple hanging from a tree. Gravity pulls the apple downward and the stem pulls upward. These forces balance each other, but they're not an action-reaction pair because they act on the same object, the apple. The true third law pairs here are the stem pulls up on the apple and the apple pulls down on the stem. And separately, the earth pulls the apple downward while the apple pulls upward on the earth. Of course, the earth barely moves because it has such a large mass, but the force is still there. This law explains how we walk. You push backward on the ground with your foot. The ground pushes you forward. Without that reaction force, you wouldn't move at all. It explains swimming. You push water backward. Water pushes you forward. It explains why a balloon zips around when you let go. The air rushes out the back, and the balloon is pushed forward in response. It also explains how rockets and jet engines work. Inside a jet engine, air is drawn in, compressed, mixed with fuel, and ignited. The expanding gases blast out of the back. That backward push on the gases is the action force. The gases then push the engine and the airplane forward with an equal force. That forward push is the reaction force. No air needed behind the rocket, no pushing off the ground. The force pair is between the exhaust gases and the rocket itself. This law even explains why you need to be careful stepping out of a boat. When you push against the boat to move forward onto the dock, the boat pushes back on you in the opposite direction. If the reaction force is larger than the friction keeping you steady, the boat moves backward, and you might end up in the water. Newton's third law is everywhere. Every push has a push back. Every pull has a pull back. Every force you apply to the world is matched instantly by an equal force applied back on you. And before you click away, don't forget to like and subscribe. It really helps support the channel and allows us to keep making more clear, useful, and enjoyable lessons just like this one.